Today we will be doing simple equations for the CAT syllabus. Suppose you have equations like these. Each of these equations is called a linear equation. Each of these is called a linear equation because the variable is in the first degree. So you can see that in this one the variable is x. So x is having a power 1. So this equation is in the first degree of x. This equation is in the first degree of y, and this equation is in the first degree of x, y and z. So these are all called linear equations, and we will be discussing about these. Now, if you want to solve this first equation, it is very simple. You just have to say that x is equal to 7 by 3. Now supposing you have an equation like this, 3x plus 2y equal to 7. There are two variables. So to solve this equation, you need another simultaneous equation. For example, let us say you are told that 3x plus 2y is 7 and simultaneously 2x plus 3y is 5. So you can solve both of them simultaneously. For example, if you multiply the first one with 2 and second one with 3 and second one with 2, then x will come 11 by 5, and once you get x, you put it in any equation. So y is coming to 1 by 5. So if you have linear equation in two variables, to solve it you need another simultaneous equation, and then you can eliminate one of them and solve and get the answer. Suppose let us say that we have a situation where the first equation is 3x plus 2y equal to 7, and the second equation is 6x plus 4y equal to 14. So coming back to the topic of simultaneous equation in two variable, suppose the first equation is 3x plus 2y equal to 7 and the second equation is 6x plus 4y equal to 14. So if you try to solve these two, you will see that you will get infinite solutions. Now, why does this happen? This happens because the second equation is in fact identical to the first. If you divide it by 2, it will become identical to the first. So both the equations are identical. So we say that the equations are consistent, but they have infinite solutions. For example, here the two equations are completely different. So in this particular case, we say that the equations are consistent with unique solution. Now suppose the two equations were like this, 3x plus 2y equal to 7 and 6x plus 4y equal to 15. In that case, these equations will become unsolvable or inconsistent, and they will have no solution. So these are the three categories: consistent with unique solution, consistent with infinite solution, and inconsistent with no solution. Speaking of three variables, suppose the three equations are like this: 5x plus 2y minus z equal to 6, 2x minus 4y plus 3z equal to 3, 3x minus 4y minus 5y plus 4z equal to 5. Suppose these are the equations. Now, in case of these three equations, if you try to solve them, then what you can do is you can multiply the first equation with 2, second equation with 5, and then subtract both of them. So if you multiply the first with 2, second with 5 and subtract both of them, you will get minus 2y plus z is equal to minus 1. You will get 24y minus 17z equal to minus 3. On the other hand, if you multiply the second equation with 3 and third equation with 2 and subtract them, you will get minus 2y plus z equal to minus 1. So you are having two equations, minus 2y plus z equal to minus 1 and 24y minus 17z equal to minus 3. If you solve both of them, you will get y equal to 2 and z is equal to 3. You take these two values and put it in any one equation, suppose the second one. So it is coming x equal to 1. So these three equations are solvable, so that means they are consistent, and you can see that they have a unique solution. Suppose you have three equations like this. Suppose you have three equations like this and you want to solve them. You will notice one thing, that this third equation is actually obtained by taking twice the first equation and the second equation. So the third equation is obtained by taking twice the first equation and adding it to the second equation. So that means these three equations, they are called linearly dependent and we also call them as consistent. And as you can see that they will have infinite solutions. So when you have three linearly dependent equations, between them they are consistent but they will give infinite solutions. The previous example which we did, they are consistent with unique solution. Now suppose if I change one of these equations, suppose the third one, then you will see that the third one is contradicting the first two. The third one is contradicting the information given by the first two. So in this case, they will be inconsistent. And therefore, they will have no solution. So that means there are total three possibilities for solving simple equations. Either they will be consistent but not dependent on each other, so then you will get unique solution, and if they are consistent and dependent, you will get infinite solutions. And if they are inconsistent, that is they contradict each other, then we will not get any solution. So that brings us to an end of this session of simple equations.